Hello everyone, I am Darshan A, Assistant Professor of Mathematics. In this session, we are going to learn about the transformation of equations. The transformation of equations is a process of transforming the given equation to another equation whose roots are related to the roots of the given equation by some relation. Suppose I consider a polynomial equation x minus a1 into x minus a2 etc. x minus an equal to 0. If I replace x by minus y, I get another equation minus y minus a1 into minus y minus a2 etc. minus y minus an equal to 0, or y plus a1 into y plus a2 etc. y plus an equal to 0. The roots of the given equation are a1, a2 etc. an. The roots of the transformed equation are minus a1, minus a2 etc. minus an. So we transformed the given equation to an equation whose roots are exactly same as that of the given equation, but their signs changed. In this session, we are going to learn many such transformations. First, we shall see how to transform an equation to an equation whose roots are increased or decreased by a quantity h. Suppose a0 x to the power of n, a1 x to the power of n minus 1 plus a2 x to the power of n minus 2 etc. plus an equal to 0 is a polynomial equation. To increase the roots of this equation by a quantity h, we substitute y is equal to x plus h or x equal to y minus h. When I put x equal to y minus h here, I get a polynomial equation b0 y power n, b1 y power n minus 1 etc. bn minus 1 y plus bn equal to 0. This is the required transformed equation. To decrease by a quantity h, we just put y equal to x minus h or x equal to y plus h. Now to find out the coefficients of this equation, bn, bn minus 1 etc. b2, b1, b0, we have a method. What we do is, suppose if this LHS is f of x, we divide the polynomial f of x by x plus h. When we divide f of x by x plus h, we get a quotient q of x and we get a remainder. We see that this remainder is equal to the coefficient bn of this equation. Now to find out bn minus 1, you divide this quotient q of x by x plus h. The remainder will be equal to bn minus 1. And continuing this way, dividing the corresponding quotients by x plus h, we get the consecutive coefficients bn, bn minus 1, bn minus 2 up to b0. Now we shall discuss an example. Find the equation whose roots are the roots of the equation x to the power of 4 minus 5x cube plus 7x square minus 17x plus 11 equal to 0, each diminished by 4, diminished or decreased by 4. To diminish the roots by 4, we divide the polynomial x to the power of 4 minus 5x cube plus 7x square minus 17x plus 11 successively by x minus 4. To use synthetic division, we divide the coefficients by x equal to 4. First, write down the coefficients 1 minus 5, 7 minus 17, 11. To divide by 4, 1 plus 0 is 1. 1 into 4 is 4. 4 minus 5 is minus 1. Minus 1 into 4 is minus 4. Minus 4 plus 7 is 3. 3 into 4 is 12. 12 minus 17 is minus 5. Minus 5 into 4 is minus 20. Minus 20 plus 11 is minus 9. Continuing the division, we get the next remainder as 55, the next remainder as 43, next as 11, and finally 1. So the transformed equation is 1 into y power 4, 11 into y cube, 43 into y square, 55 into y minus 9 equal to 0, where y is x minus 4. Next we shall discuss one more example. Increase the roots of this equation by a quantity 2. To increase the roots of the equation by 2, we divide this polynomial successively by x plus 2. If x plus 2 is 0, then x is minus 2. To use the synthetic division, we divide the coefficients of this polynomial successively by minus 2. When I use the synthetic division, I get the remainders as minus 19, 51, 0, minus 8 and 1. So the transformed equation is y power 4 minus 8y cube plus 51y minus 19 equal to 0. Next we shall see how to remove the second term of a polynomial equation. Consider a polynomial equation a0 x to the power of n, a1 x to the power of n minus 1, a2 x to the power of n minus 2, etc. an minus 1 x plus an equal to 0. To remove the second term of this polynomial equation, we have to diminish the roots of this equation by a quantity h, where h is equal to sum of the roots divided by degree of the equation. We know the formula for sum of the roots, which is equal to minus a1 by a0 whole divided by the degree is n. So when we diminish the roots of this polynomial equation by a quantity minus a1 by n a0, we get a polynomial equation in which the second term will be absent. Now we shall see this by an example. Solve the equation x to the power of 4 minus 8x cube minus x square plus 68x plus 60 equal to 0 by removing the second term. First, to remove the second term, we have to diminish the roots of this equation by a quantity h. H is equal to sum of the roots by degree of the equation. Sum of the roots is minus of minus 8 by 1, which is 8. The degree of this equation is 4. So we have to diminish the roots by a quantity h is equal to 8 by 4, which is equal to 2. Or we have to substitute y equal to x minus 2 or x equal to y plus 2. We shall use synthetic division. We divide the coefficients successively by x equal to 2. I have written the coefficients 1 minus 8 minus 1 68 60. When I divide successively by 2, I get the remainders as 144, 0, minus 25, 0 and 1. So the transformed equation is y power 4 minus 25y square plus 144 equal to 0. This equation is a quadratic equation in y square, so we can easily solve this by using quadratic formula. We get y square is equal to 9 or 16. So y should be equal to minus 3 plus 3 minus 4 and plus 4. Now to find out the roots of the given equation, we have y is equal to x minus 2 or x equal to y plus 2. Substitute the values of y here, we get x is equal to minus 1, 5, minus 2, 6. These are the roots of the given equation. Now we shall see how to multiply the roots of the given equation by a given quantity. To transform this polynomial equation to an equation whose roots are equal to those of the given equation, each multiplied by a quantity m, we replace y by mx or x by y by m. When I replace x by y by m, here I get y by m per n. Here I get y by m per n minus 1. Here I get y by m per n minus 2. Here I get y by m. When I multiply throughout by m to the power of n, I observe that to multiply the roots of an equation by a quantity m, we just multiply the consecutive coefficients of the given equation by 1 m, m square, etc. m to the power of n, provided the equation is a complete equation. That is, it should contain all the powers from 0 to n. Now we shall see this by an example. Find the equation whose roots are thrice the roots of the equation is x cube plus 2x square minus 4x plus 1 equal to 0. First consider this equation. We observe that this is a complete equation. This contains all the powers from 3 to 0, 3 to 1 and 0. I multiply the coefficients by 1, 3, 3 square and 3 cube. I get x cube plus 6x square minus 36x plus 27 is equal to 0. So this is the required equation whose roots are thrice the roots of the equation x cube plus 2x square minus 4x plus 1 equal to 0. Finally, we see how to transform an equation into an equation whose roots are reciprocal of the roots of the proposed equation. To transform a polynomial equation to an equation whose roots are reciprocal of the roots of the given equation, you just replace x by 1 by y. Consider an example. Suppose x to the power of 4 minus 9x cube minus 8x square plus 5x plus 1 equal to 0. To transform this to an equation whose roots are reciprocal of the roots of this equation, we replace x by 1 by y. I get 1 by y whole to the power of 4 minus 9 into 1 by y whole cube minus 8 into 1 by y whole square plus 5 into 1 by y plus 1 equal to 0. Now multiply throughout by y to the power of 4. I get y power 4 plus 5y cube minus 8y square minus 9y plus 1 is equal to 0. This is the required equation. In this session, you have learned how to transform the given equation to an equation whose roots are increased by a given quantity, decreased by a given quantity, multiplied by a given quantity, and you know how to transform an equation in which that second term is absent. You know how to get an equation whose roots are reciprocal of the roots of the given equation. And you observed sometimes the transformed equations are much more simpler to solve than as compared to solving the actual equation. In the coming sessions, you are going to learn how to implement transformation of equations to solve the complicated equation.